Yo, what's going on guys, Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And in this video tutorial we are going to be taking a look at the bubble sort sorting algorithm. So this is yet another sorting algorithm which we've been covering in the past couple of videos in this data structures and algorithms course. By the way, if you have missed any of the previous video, I'll drop the link of this entire course or playlist in the video description. In the previous few videos we've been covering the sorting algorithms like insertion sort, selection sort, and then there are a bunch of other data structures oriented tutorials in this playlist. So if you have missed any of them, you can check it out. And with that being said, let's get started with today's topic, that is bubble sort sorting algorithm. So we'll divide this sorting algorithm into two parts, that is two videos. So this is part 1, and in this part we are going to be covering what exactly is the bubble sort. We'll go through a little bit of theory as you can see. Then we will move on to the working. And lastly, we will also see the algorithm, which we will actually dry run and take an example and go step by step to see exactly what happens in bubble sort. And that is really important, so make sure you watch this video till the end. And in the second part, that is the next video which will come after this, we will implement this bubble sort using C++ programming. So before you actually jump to the direct implementation, it is very important that you understand the behind the scenes working, the algorithm of this sorting algorithm. So we'll quickly start off with a little bit of theory. Now bubble sort is one of the simplest sorting algorithms, just like selection sort and insertion sort, and it works by repeatedly swapping adjacent elements if they are in wrong order. Okay, so if you're making a note of points, if you're making some theory on bubble sort, you can note this theory down, you can just screenshot it. Of course, I will be sharing all the details on our official website as well. Now this algorithm is suitable again for small data sets because it is not really efficient when it comes to time complexity. If you see, the time complexity is pretty much the same as selection sort and insertion sort, which is n square. We will have a dedicated video on asymptotic notations and space and time complexity. So it will be there in this data structures course itself. If you're confused, you can check that video. Now moving on, it is known as bubble sort because with every complete iteration, the largest element bubbles up towards the last place or the highest index. Just like water bubbles rise up to the water surface. That's the reason why it is named as bubble sort. But this line is important. Just note these points down because you will understand them when we actually move ahead and see the working. So this was a little bit of theory. Let's quickly move on to the working so you better understand bubble sort. Okay, so when it comes to the working, you can break it down in 4 simple steps. So I'll just read it and it will make very basic sense. But then the algorithm will make it more clear, which will come after this. So step number 1 is start with the first element at index position 0. So we are going to be dealing with arrays. You can see there is an array over here. We're going to work on this. So we will start with the first element. We compare that current element with the next element of the array. So the comparison is happening. After the comparison happens, we check if the current element is greater than the next element of the array. And if it is greater, then we have to swap them. Now this is obviously when we want to perform sorting in ascending order. When it comes to descending order, if the first value, that is the current element, is greater than the next element, then you don't need to perform swapping, right? When you are performing sorting in descending order, the greater element should be on the starting side, and that is on the left hand side, and the smaller element should be on the right hand side. So depending upon whether you are performing sorting in ascending and descending, the algorithm will also change. So currently we are sorting in an ascending order and the steps are applying only for that. Moving on, if the current element is less than the next element, move on to the next element. So if current element is smaller than the compared element, that is the element to the right of it, then we don't need to do any swapping, right? Then we just have to move to the next element. And step number 4 is we have to repeat step number 1 till the list is sorted. So we have to keep on going from step number 1, 2, 3. We have to keep on repeating it till the list is sorted. So this makes very basic sense of how we are going step by step through the sorting algorithm. But this is still in theory, in text. How is the algorithm, right? So that is the main important part. So let's now actually see the actual algorithm. Okay, so this is the complete algorithm from start to stop. We will go through each of the statements step by step. Before that, A is the name of the array, N is the size of the array, and over here you can see I have made a list of variables which we are gonna track the values for. Okay, so N is the size of the array, and for our example, which is this integer array over here, you can see of size 5, the size is going to be constant, so that's why I've written 5 over here. Apart from that, we have 2 more variables, and these are iterators, which are going to be used in iteration purpose in the loops. Okay, you'll understand that in detail as we move ahead. So we are taking an integer array of size 5. You can see the elements also 9, 7, 3, 6, 2. So at 0 index we have 9, then 7, and so on and so forth. Obviously they are not sorted in any proper order. We have to perform bubble sort on this array and make it ascending order. So the best way to understand this algorithm is to actually apply this algorithm, dry run it live, and visually understand what exactly is happening. And to do that, whenever I say dry run, what you have to do is we have to keep a track of all the variables that are involved in this algorithm. Okay, so let's start off with the algorithm and you'll understand more. So starting off, we have step number 1. Now step number 1 is to declare variables I and j. So that's why I have written I and j over here, because when this algorithm is running, we will keep a track of I value and j value. Okay, moving on to step number 2, we have a loop. So at step number 2, we have our very first outer loop. So this is the first loop. We're going to be needing 2 loops. So the first loop runs from I equals to 0 to I less than n. So from 0 to less than n. Now n value is 5, right? So from 0 to 4 it will run. So the outer loop is going to run from 0 to 4, which is basically 5 times, right? So that is that. So let's start off, and initially obviously I is going to be initialized to 0. So we'll write I value as 0 over here. Now coming inside, we have step number 2.1. Now step number 2.1 is immediately a second loop wherein we have declared, or where we are using j as the iterator. So j equals to 0, and the condition over here is j less than n minus I minus 1. So you'll understand why we need this condition. This condition is very important to understand, and it will be more clear when we actually start with the dry running process. Now this is the inner loop. So initially obviously j is 0, and the condition is j should be less than n minus I minus 1. So what is the value of n currently? N is 5, right? So 5 minus, what is the value of I? 0 minus 1. So ultimately this will equal to 4. So is j less than 4? What is the value of j? Initially, for the first time we assign 0. So 0 is obviously less than 4, right? So now we will go inside the second loop or inner loop. Now inside this loop, what is happening? A comparison is happening. Remember, we were comparing the first element and the element which is just to the right of it, right? So that comparison is happening over here. So we are saying if a of j is greater than a of j plus 1, that is, if the first element is greater than the element which is just right to it, then we have to perform swapping. Now initially, what is j value? You can see we are tracking it as 0. So a of j is 9, right? The value at index position 0 is 9. So we are saying is 9 greater than a of j plus 1. So 0 plus 1 is 1. So a of 1, what is the value of array index 1? What is the value at array index 1? It is 7, right? So is 9 greater than 7? It is greater than 7, right? True. So this if condition becomes true. So we go one more step inside the if condition. And now inside this if condition, we have the swapping protocol. Okay, so this is swapping happening over here. Of course, I have not written the code for swapping because this is just the algorithm, right? This is not the complete syntax. So when swapping happens, what we do is we switch, or we place 9 over here and we put 7 over here, right? So let's do this swapping also side by side. So we just did this swapping over here. We are at this point, right? So I'm gonna say 7 over here, 9 over here, and 3, 6, 2 I'm gonna keep as it is. Now don't worry about this statement and this green margin. Also this arrow I'll explain after the complete step is over. You'll understand it very well. So let's continue with our algorithm. So we were at this step, we did the swapping, we said end if, and we are at the end of the inner loop, right? So this is end loop of the inner loop. So we again go to the start of the inner loop. Now j becomes 1, okay? So we are using a for loop, we are going to be using a for loop, j will be incremented. So now j value will become 1. So let's update that. Okay, so now j value is 1. So we are again comparing, is j less than n minus I minus 1. Now n value is going to be static, right? Phi is not going to change. The size of the array will never change. Phi minus I. What is the value of I still? I is still 0, right? Because we have not reached at the end of the outer loop. We are still inside the inner loop. So I is going to be 0 only. So phi minus 0 minus 1 is 4 again. j has incremented to 1. Now is 1 less than 4? Yes. So we will again go inside this loop, right? So let me just erase this inner steps. So again we will go inside this inner loop 2.1.1. Now here we are again checking if a of j greater than a of j plus 1. Now what is a of j? Currently j value is 1. So what is the element at index position 1? Now we have to see the newly updated array, okay? And not this array. So here you can see a of j, that is a of 1 is 9. So I'm gonna write 9 over here. Is 9 greater than a of j plus 1? So j is 1, j plus 1 is 2. So a of 2 is 3, right? The value at index 2 is 3. So is 9 greater than 3? Yes. This is also true. If it is true, then we have to do the swapping, right? So now again we will swap 9 and 3. So now 9 will go over here and 3 will come over here. So let's make that change. Okay, so you can see again the side by side swapping has happened. Now we will come at the end of the if, we will come at the end of the inner loop and again go to the start of the inner loop. Again j will be incremented and now j will become 2, right? So let me update that over here. J will become 2. Now 2 is still less than 4, right? Because n is 5, I is 0 and 1 is 1 obviously. So 5 minus 1, 4. So 2 is still less than 4. So we'll again go inside this inner loop. Again the comparison is now happening. So now a of j is a of 2. So what is a of 2? 9, right? Element at index position 2 is 9. And a of j plus 1, that is 2 plus 1 is 3, right? So a of 3, that is element at index position 3 is 6. So now again this comparison is happening. Is 9 greater than 6? So 9 is greater than 6, obviously true. So again we will go inside this perform swapping. So now 9 will come over here and 6 will be coming over here. So let's make that change. So after this swapping we will come to the end of the if, we will come at end of the inner loop, again go to the start of the inner loop. Now the j value will become 3. Let's update that. 3. Let's update it over here. 3. Now 3 is still less than 4. The 4 value is still the same because j should be less than n minus I minus 1. N is 5, I is 0. 5 minus 0 is 5. 5 minus 1 is 4. So 3 is still less than 4 obviously. We will go inside this loop. Again a comparison is happening a of j. Now j is 3. The value at index position 3 is now 9. So is 9 greater than j plus 1? J plus 1 is 4. The value at index position 4 is 2. Is 9 greater than 2? Yes. So then we will do the swapping again. So now 9 will be kept over here, swapped over here, and 2 will come at this place. So let's do that swapping. So that swapping is done. We will do end if, we will come at end of the loop. Then we will go again start of the loop, of the inner loop. J will be incremented. J will now become 4. And now if you see, the condition becomes false. The loop condition, that is the inner loop condition, becomes false. 4 is not less than 4. It is equal to 4 but it is not less than 4. And the condition is it should be less, right? So now we will not execute this inner loop. Now we will directly come at the end of the loop from this place. Okay. So this is the end of the inner loop. After this we will come at the end of the outer loop, and now we will go to the start of the loop. And this start of the loop is the start of the outer loop. Okay. And now I will become 1 because I still has to go from 1 to 4, right? So we are at 0 and now I will become, sorry, we have to go from 0 to 4. So now I will become 1. Let's change that, make it 1 over here, and now we will again go to the inner loop. So one complete iteration of the outer loop resulted in the largest value to go to the rightmost position. So if you see, after one iteration of the outer loop on this array, this 9, which was the largest in this array, you can see it is the largest, right? It got shifted to the end of the array. So this is what bubble sort is doing, and this is what that theory statement was saying, that the reason it is called bubble sort is because after one complete iteration, the largest element bubbles to the rightmost end of the list or array. And you can see that is exactly what happened after one complete iteration of the outer loop. And now you can see that from the next time, we only need to sort these 4 values because the largest element has already come to the end. So we are only interested in sorting 7, 3, 6, 2. We don't need to bother about this one, right? So now let's go ahead and start off with the second complete iteration, and then you'll understand what this condition is all about, okay? So when we start with the second iteration, you can see that we have I equals to 1, I has incremented, right? So we come over here and now this loop again starts to execute. So j is initialized to 0 again. So we'll make j equals to 0. But now if you see, we have to go from 0, which should be less than n minus I minus 1. What is the value of n? 5. But now you can see I has become 1. So 5 minus 1 minus 1. So now we will only iterate from 0 to 5 minus 1 minus 1, which is 3. So 0 through 3. In the first iteration, we were going from 0 to 4. But now in the second outer iteration, we are only traversing from 0 to 3 because one of the element is already sorted and it has been shifted to the rightmost end of the array. Okay. So now let me just write it over here. We will go from 0 to 3. And now initially obviously j is 0. So is 0 less than 3? Yes. So we will go inside the second loop, that is the inner loop. Over here we are again going to check if a of j is greater than a of j plus 1. And now what is a of j? J value is 0. So element at index position 0 is 7, right? You can see. So we say if 7 greater than j plus 1. Now j is 0, 0 plus 1 is 1. So a of 1 is 3. You can see element at index position 1 is 3. Is 7 greater than 3? Yes, it is true. So we'll go inside over here. Now since 7 is greater than 3, we have to perform the swapping, right? So 7 will come at this place, 3 will come at this place. So let's do that swapping. So I'm going to do the swapping over here. So 3 will come over here, 7 will come over here, 6, 2, 9 will be as it is. Okay. We'll come at end if, end loop, that is ending the inner loop. Again go to the start of the inner loop. J now will become 1. Let's do j equals to 1. Is 1 less than 3? Yes. So we will again go inside, changing j value over here also. Make sure you keep a track of all the variables which are changing inside the algorithm. This will help you in dry running. Now again we will check if a of j. So what is a of j? That is a of 1. You can see from the diagram it is 7. Is 7 greater than j plus 1? That is 1 plus 1, a of 2. The value is 6. Is 7 greater than 6? Yes. So then we have to again do the swapping. So swapping 7 with 6. So let's change it over here only. 6 and 7. Right. So again end if, end loop, come over here. J will now become 2. Is 2 less than 3? Yes. Again go inside. Make the comparison if a of j. Now j has become 2, right? Let's change it over here also. Now a of j is a of 2, which is again 7 over here. Is 7 greater than a of j plus 1? What is j plus 1? 2 plus 1 is 3. So a of 3 is 2. Is 7 greater than 2? Yes. So again swap 7 and 2. Let's make that change. After the swapping we again end if, end the inner loop. Again go to start of the inner loop. J now becomes 3. Let's change it over here also. But now you can see this condition becomes false because 3 is not less than 3. 3 is equal to 3 but it is not less than 3. So we will come outside the inner loop. We will go at this place, but this is end of the outer loop. So again the outer loop is also ended. So we'll go to the start of the outer loop. And now I value becomes 2. Okay. So this was complete second step. And now you can see after complete second step, number 7 is shifted to the end. From the diagram also you can see 7 is the second largest element in this entire array. You can also see that, right? So 7 got shifted over here and not over here because the end now is this. So after step number 1, you can see this green dotted line. This is the end of the array. So that's why 7 got shifted at this position. Now this dotted line has increased or moved a little bit to the left, one step to the left. So you can see the sorting is basically happening from this side. All the larger elements are being shifted to the rightmost area. So now I'm assuming that you already have got an idea about what exactly is happening after these two steps. So basically in step number 3 what will happen? Number 6 will be shifted to the end. So you can see 7 and 9 are already sorted. So 3, 6, 2, which is the greatest one? 6. So 6 has to come over here, right? So 3 and 6 will be compared first. 3 is smaller than 6. So no swapping will happen. So 3 will remain as it is. Then 6 and 2 will be compared. 6 is greater, so 6 has to be moved over here. So 2 will come over here. 6, 7, 9. will be the result of step number 3. Of course, I'm not going through the algorithm. I'm assuming that you've already got a hang of it. If not, you can pause the video and keep on dry running this algorithm and keeping a track of I and j values. You'll ultimately land to this result only. So this is step number 3. After step number 4, we have only 3 and 2 to be sorted, right? So at the 4th step, obviously 3 and 2 will be swapped. So 2 will come over here. We have 3 coming over here. Then we have 6, 7 and 9. And you can see that the entire array is sorted in ascending order. This green arrow is for basically sorting happening from the right to left, okay? Because all the larger elements are shifted to the right. So yeah, this was the complete bubble sort algorithm, and I hope you understood the algorithm. We dry ran it, we also visualized it. This is the basic way to go ahead when you don't understand a particular algorithm. Just write down the steps, note down the variables, and go step by step in the loop, keeping a track of those looping variables. So yeah, this was the bubble sort algorithm. We covered the theory, we covered the working and the algorithm. In the next video tutorial, we'll implement this bubble sort algorithm using C++ programming language. You can use any other programming language, but I'm going to stick to C++. The algorithm is obviously going to be the same. So that's it for this video, guys. If you like this video, please give it a thumbs up. Let me know in the comments how this video was. Did you understand this algorithm or not? If you have any queries, you can put them in the comments. Please do share it with your friends also if you find this very important. And I'll see you guys in the next video. Peace.